Good morning, everyone. I hope you all had a great weekend. We're coming up towards the home stretch here as we start to go into the last month of the school year. So today and on Wednesday with geometry, we're going to be reviewing the two algebraic types for solving a system of linear equations. Last week, we did a basic run through how to check whether something was a solution to a linear system. Checking out the IXLs, most of you all did a very good job with that. So in this case, we're going to solve linear systems by substitution. So to give a little bit of background, so a system of equations is a problem in which you have two or more equations with two or more variables. Most of the time, those variables are x and y, but those variables can be any letters. There are several ways to solve a system of equations, but the three that you have probably learned back in Algebra 1 were graphing, substitution, and elimination. Substitution and elimination are algebra-based methods, which are plug in, solve equations, things of that nature. And those are the two methods that we're going to focus on. So let's start with substitution. Now, main thing to keep in mind here, substitution is not new. You've done substitution every single time that you have taken a number or a variable and plugged it into an expression. So substitution is not new. You've been doing it pretty much the entire year. So, for example, if you have 6x minus 5 and they tell you to evaluate when x equals 4, you've done this 1,000 times. Take 4, plug it in for x. That gives you 6 times 4 minus 5. 24 minus 5 is 19. That was substitution. We can do the same thing when it comes to a variable. 8x plus 3y, they're telling you that y is equal to 2x. So y is equal to 2x. So we're going to take 2x and plug it in for y. So that would give you 8x plus 3 times 2x. And then we simplify it. 3 times 2x is 6x. 8x plus 6x is 14x. So remember, when you combine like terms, x plus x stays x. You do not make it x squared. All right. So example 3, same type of problem, 2x plus 3y, and they're telling you that y is equal to 5x minus 3. So take 5x minus 3, and since they told you it was equal to y, plug it in for y. That gives you 2x plus 3 times 5x minus 3. And again, simplifying it is distributive property. 2x plus 15x minus 9. Combine like terms, 2x and 15x is 17x minus 9. And that simplifies and takes care of that problem. So let's do one more because everything has been y equals, so let's do one with x equals. 9x plus 4y, evaluate when x equals 3 minus 2y. So take 3 minus 2y and plug it in for x. Same type of problem, we're just plugging it in for x. So notice that all we have now are y variables. Distribute, 9 times 3 is 27. 9 times negative 2y is negative 18y. Then combine like terms. Negative 18y plus 4y is negative 14y. So again, it's not 22y because there's a minus sign in front of that 18. So you have to treat it like a negative. So this whole first part should be nothing more than just some algebraic review. So now when we solve a system of equations by substitution, we're literally doing just this. Taking a number or an expression, substituting it in, and then solving out the rest of the problem. So let's transition to that. When solving a system using substitution, you are plugging one number or expression that is already set up for you into another equation which is not. So the term already set up for you means x equals something or y equals something, or whatever variable they so happen to be using for you. When finished, your problem should only have one variable. So that's a clue to let you know whether or not you did it correctly. Then solve the problem. Remember, the goal is to solve for all of the variables in the problem, and to write your final answer as an ordered pair. That means when you give your answer, you write it in parentheses, one number and then another number. Now, how do you know what order it goes in? Alphabetical order. So most of the time it's x comma y, but if it's not x and y, you always go in alphabetical order. So let's start with example 6. So example 6 is a very, very basic example. X equals 1, and then x plus 2y equals 5. So with this very basic example, they're telling you that x is equal to 1. Take 1, plug it in for x. That gives you 1 plus 2y equals 5. And this solves itself pretty easily. Subtract 1 on both sides. 2y equals 4. Divide both sides by 2. Y equals 2. So x equals 1 and y equals 2. So your answer is 1, comma 2. X comes before y. And that takes care of that. Example 6. Y equals 4x. And 3x plus 2y equals negative 66. So same principle. Except instead of it being a number, it's a variable. Take 4x, plug it in for y. Take 4x, plug it in for y. So that gives you 3x plus 2 times 4x equals negative 66. So now we solve it down. 3x plus 8x equals negative 66. Combine like terms, 3 plus 8 is 11. Divide by 11, x equals negative 6. So now we've got part of the answer. Now we just need the other part. We know what x is equal to. We now need to find what y is equal to. So to find what y is equal to, take negative 6, plug it back in. So y equals 4 times negative 6, which is negative 24. So your answer would be negative 6, comma, negative 24. That's that. Problem's over. So first two examples are very general, very basic examples of substitution. Let's do a couple that are a little bit more developed. So example 7, You have 7x plus 4y equals negative 13, and x equals negative 6y plus 9. Blow this up a little bit just to give myself a little bit more room. So, again, you have x equals something, so that's a giveaway to do the substitution method. So take negative 6y plus 9 and plug it in for x. Take it, plug it in for x. So that gives you 7 times negative 6y plus 9 plus 4y equals negative 13. Now we distribute. 7 times negative 6 is negative 42. 7 times 9, 63. Combine like terms. Negative 42 plus 4 is negative 38y plus 63 equals negative 13. Combine like, well, not combine like terms. We subtract 63 on both sides. Negative 38y equals negative 76. Divide both sides by negative 38, you get y equals positive 2. Remember, a negative divided by a negative is positive. So now we know what y is equal to. We plug it in for x. Now notice you have two equations to use. You can pick whichever one you want. It shouldn't matter. You'll get the right answer anyway. So I'm going to take y equals 2 and plug it into the x equals equation. That gives you x equals negative 6 times 2 plus 9. Negative 12 plus 9, negative 3. So your answer is negative 3, comma 2. Remember, x comes before y in the alphabet. So x comes before y in your answer. And that's it. Problem's over. So example 8. So example 8 is a special circumstance with substitution. And that's because you have two equations in which both of them already are equal to each other. Both of them are equal to the same variable. So you have y equals something and y equals something. So you have y equals 3x plus 2 and y equals negative 4x plus 23. They're both equal to the same variable. So when that situation happens, you can set equal to each other. You can set them equal to each other. So this becomes 3x plus 2 equals negative 4x plus 23. Set them equal to each other, and now we solve it. So as you can see, we have variables on both sides. So I'm going to take negative 4x and move it to the left-hand side. You could have just as easily taken 3x and moved it to the right. It's your choice. So the opposite of negative 4x is positive 4x. Three plus 4 gives you 7. So 7x plus 2 equals 23. Subtract 2 on both sides. You get 7x equals 21. Divide both sides by 7. X equals 3. So now we know what x is equal to. We have to figure out what y is equal to. You've got two equations. Pick one, plug it in, and solve it out. So I'm going to choose the first one. Y, felt like it. So you get y equals 3 times 3 plus 2. So 9 plus 2 equals 11. So your answer is 3 comma 11. Three comma 11. That's it. That's all. So in essence, that's what substitution is made of. Substitution is when you are taking two equations in which one of them is already equal to set up for you, x equals or y equals, plug it in, work out the rest of the problem, and then find the two variables. So you're plugging one equation into the other. So with that, you should expect to have an IXL assignment that takes you through solving systems of equations. And then after that, you'll have a Google mini quiz to check to make sure that you're okay. Keep in mind, with this Google mini quiz, the first couple of problems, they will not let you move on until you get the right answer. So if you notice that it's telling you incorrect answer, please try again. It's because it's not letting you move on until you get the right answer. So you're going to have to practice and make sure that you're doing it the right way. With that being said, have a great rest of your Monday, and I'll talk to you soon.